So I'm going to talk about updates to the OSDF, the Open Science Data Federation monitoring system. So quick motivation, the Open Science Data Federation supports the data needs of organizations and individual users. The caches and origins are spread throughout the world, and we have a nice little visualized globe of all the caches and the origins. And the monitoring cache is imperative to watch for working set sizes, for cache thrashing, and just for general utilization of the Federation. In a quick summary slide, we over the last, I think we're almost at 2 years now, we completed 2 validations, a correctness and a scale validation. Found a few minor issues which we corrected during the validations, but we did find a large problem with the transport mechanism between XRootD servers and our accounting collector. We solved this by writing a simple shoveler that reliably transports monitoring and accounting packets between the XRootD server, which is our caches, our cache software is built off of, and our accounting pipeline. So I want to clarify that OSDF monitoring is the same thing as XRootD monitoring. We Open Science Data Federation caches and origins are built off the XRootD technology, and therefore we use their monitoring output. We conducted 2 validations of the existing OSDF XRootD monitoring to find and correct any issues, and I have links to these in the presentation. A correctness validation to make sure that every transfer is captured correctly through our accounting, and a scale validation to make sure that our monitoring scale to the expected size of the OSDF current and future deployments. And during our XRootD monitoring, which uses the detailed monitoring, if you look up the XRootD documentation, this is the overflow. This is the flow of data through the monitoring pipeline. As it currently stood before the shoveler was developed, the XRootD servers would send UDP packets directly to the monitoring collector, which would then use a message bus to send it, depending on if the usage was OSG, stash cache usage, or OSDF, or if it was WLCG usage, because we use the same monitoring pipeline, so we just split. The reason that we found that XRootD detailed monitoring is hard, and the reason for that is manyfold. The collector has to keep a lot of state. Any sort of packet loss, since we're talking about UDP, there will definitely be packet loss, means that we have to keep TTL on the actual state. The time between a client connect and a file close, for example. So on the right is the flow of packets that we receive, and each one of these can be a completely separate UDP packet. So the client connect, some path information, the file open event, any reads that happen, and then finally the file close. Each one of these is a separate UDP packet, or can be a separate UDP packet. And therefore, to get the full picture of what a client did on a server, the files that the client opened and how much they read, you have to join all these different packets, which can come hours between the client connect and the file close. So you join all this, and if you're missing any one of them, then you are missing a significant amount of data. For example, if you miss the file open, then you have no idea what client opened this file. You also don't know what file was actually opened because you missed the file name. And so a lot of the times before the shoveler, we would get maybe a client connection, and then we would never get a file open, and we just got a file closed. So we know that some file was read, 100 megabytes, and how many read operations, but we have no idea who read it. We have no idea what file was actually read. And so this is the reason that the detailed monitoring is difficult to parse. So from our first validation, we found a few bugs in the collector. For example, we had an incorrect assumption that the sequence numbers in the monitoring packets were a reliable measure of missed packets. They are not. We fixed it in XRootD so that they are once again a a reliable measure of missed packets. But the larger issue was UDP fragmentation. So the XRootD servers were sending out very large UDP packets. And UDP fragmentation was causing significant loss. UDP fragmentation happens when the MTU of when the UDP packet is larger than the MTU of a network, then that UDP packet will be split into multiple packets and then sent across the network. So UDP fragmentation is a known problem. Cloudflare knows about it very well. And even this very Zoom meeting that you are watching uses UDP packets, and Zoom knows about it because they explicitly set a don't fragment bit in the packet header, and they never send a packet larger than about 1,400 bytes. So Zoom very much knows that fragmentation is a problem, and they fight it by making small packets and this special bit flag, which XRootD did not do. In our test performance and validation 2, the second version of our validation, we wanted to find out if sending monitoring data simultaneously from multiple XRootD servers would show any kind of data loss, and what's the maximum rate at which our collector can process these monitoring packets. We set up several tests with number of servers, number of files being requested per second, and we saw some loss at the higher end where we started seeing hundreds of files being read a second, connections and files being read a second. We started seeing some loss, which is expected as UDP packets overflow network routers or overflow the bandwidth available in the network, then the UDP packets will be dropped. So fragmentation causes loss of packets, leading to missing data. And when scaling the number of nodes and number of packets, the packet loss also occurs. So our solution that we developed was a XRootD monitoring shoveler. So we designed and developed the shoveler from this UDP packet to a resilient format using a message bus. The shoveler is simple. It does no parsing or aggregation of records. It's designed to be very simple. So it receives the packets. It does a very simple validation of the packet to make sure that it is an XRootD monitoring packet. And then it packages it and sends it to the message bus. So the monitoring, then XRootD monitoring system has two components. The shoveler that was developed, it runs at sites, it collects these UDP packages, it packages them, and then a centralized collector that's very complicated. It runs centrally because it's complicated, and it keeps a lot of state. It parses the monitoring packets, and then it also processes and extracts the VO information, the application information, the types of transfers, those type of things that sometimes can update frequently. And so this is the flow of data now with the shoveler. So at the top, you'll see a regular site like that you would see on a CMS tier 2. On the bottom, you'll see a cache site on the OSDF. Both of them have shovelers nearby the XRootD servers. The shoveler then sends the messages to RabbitMQ, which sends them to the collector, which merges them with the legacy UDP packet stream, and then all usage is sent to Grok, which is an Elasticsearch cluster. So some design decisions. The shoveler was purposely simple, and the collector, which is centrally managed, performs all the stateful logic. So sites are not expected to run their own collectors. When a shoveler is disconnected from the message bus, additionally, it will write messages to the disk and replay them when reconnected. On our testing, a production shoveler will write about 30 megabytes of data a day to disk if it's disconnected, so it's not a lot of load. So the shoveler is available. It'll be for download. It will be available in OSG repos now. It's currently in OSG testing. It can be deployed as a stack binary, an RPM. It also has a Debian package, a Docker image, or in Kubernetes. The shoveler has been deployed already at several sites. We will deploy the shoveler as a sidecar with the distributed caches of the Data Federation. And we are in talks with XRootD to have the shoveler become part of the XRootD repository and software. So some quick statistics of the Open Science Data Federation. For the busiest cache, Chicago's Internet 2 cache, this is in the last year. Cache was the busiest cache with 6.2 petabytes of data transferred in and out. Kansas was second. This Tiger one is the CHTC cache. It comes up as one of the hosts. Then you go on down the list. You see Syracuse, UCSD. UVA Lite is, I believe that is in Amsterdam. That's mostly a LIGO cache for Europe. This is the usage by week for the last 1 year. This is a bar graph of all the different users. So previously in the year, Minerva was using it quite a bit, and then LIGO picked up right around last October. And then more recently, Bioinformatics OSG Connect user and Computer Science OSG Connect user were using the OSDF quite a bit. So in total, we had 92 researchers, 9 collaborations, and 1 campus that used the OSDF in the last year. And the 92 researchers are individual researchers, mostly from OSG Connect. For new developments, the XRootD added a G stream recently, which includes cache information such as hit rate and bytes read from origin versus the cache. And we'll be doing more integrating with this data. Fabio has done a great job of starting this integration. And for example, this is the hit ratio for one of our caches at UCSD. And you'll notice that, let's see, on the 10th, the hit ratio dropped significantly, but then it's been pretty steady at about 100% cache hits since then. So in summary, we completed 2 validations, correctness and scale. We found a few minor issues, but the largest problem we found was the transport mechanism between XRootD servers and our accounting collector. We solved this by writing a simple shoveler that reliably transports these packets between the XRootD server and our accounting pipeline. And that's my presentation and a few acknowledgements for Path and Iris Hep. And I'll take questions.
Thanks a lot, Derek. Even before I could do my filler question, I see Todd Tannenbaum has jumped in. Todd, feel free.
Yep, great talk, Derek. Thanks a lot. So a lot of the talk focused on what I would consider, I guess, accounting of what's going on in OSDF. I'm wondering, is there a health monitoring? Like if I have a job that blows up and it blows up at a given site and I know it's trying to use OSDF, is there a site I can look at yet to, that shows green or red of all the caches, and I can be like, oh yeah, the cache that's serving this area is busted or broken or something like this?
Yeah, so that's there's a couple of answers to that. I don't know that there's a public site that shows that. We definitely have internal monitoring that pokes all the caches. I think every 3 seconds, it checks to make sure that they're functional. And also all of the client tools for the OSDF, whether that's either the Stash CP or the Stash plugin for Condor, or the using CVMFS, they all try multiple caches before they finally give up and return a failure. And so I think Stash CP tries 3 caches. I think CVMFS also tries 3 before it finally gives up.
Great, thanks. We're good on time. So I see Valerio has a question.
So yeah, maybe it's kind of related question is like, if I don't know if you have a real-time dashboard. So what is the delay between collecting the data and the logs and the ability to present it to the users? So is that something that is done offline, or do you have kind of a visualization dashboard that show those things live or live?
So let me see if I can. So is your question like, how soon after a file access is that information in our accounting? Is that what you're asking?
Yeah, and how quickly can you see? Do you have a dashboard that can, with some delay, show you that something is going on? so that you
Right.
can see it, maybe trigger an alert or whatever, right?
Right. So when I was talking about how we do all the joins, let's see if I can go back to that. Okay, so these things can happen. These are in order, but they can happen hours apart. And our accounting only finally gets the message on the file close at the very end. So after a file is closed, there's a few buffers, but on the order of about 1 minute after, it'll be in our accounting database and it can be visualized.
Oh, okay, that's cool.
Probably maximum of like 2-3 minutes, depending on different buffers.
Okay, so you can really do kind of a real-time update.
Yeah, and I frequently do this when we're teaching at the OSG user school in the summer. We usually we teach using the OSDF, and I will always on the big screen in the front have a live view of all the summer school students that have used OSDF. Depending on how far they are, and while they're doing the exercises, they see their name show up, and so it's within a minute or two of them
That's really cool.
viewing the data.
So I see no other hands. We do have 1 minute. So Derek, I guess I had a question. So you showed the monitoring, some various pictures. Is there kind of, I mean, this is related to what Todd was asking. Is there kind of a Grok-like view, kind of, I know you shared that the new dashboard which is a little more for, I guess I think of it as very nice PR, but is there a kind of Grok? This is ready for humans.
No, I don't think so. So this is, I think, what you were talking about before. That's
Yeah.
a little more PR. No, I don't think we have like a status page. Is that what you're asking? A status page of the specific caches of whether they're functioning or how much they're currently transferring in and out, those type of things.
Yeah. Well, that not only for that, but the origins as well, right? I think that's what maybe Todd was getting at.
Okay. Yeah, we don't. No, we don't have that, but that would be very interesting to add.
Oh, and I see a Andrew's raised his hand. We'll allow it. Andrew.
Oh, hello. Okay, I got it. Yeah, so I just had a question. So, and I might have missed some of the nuance to it, but when the I guess let me just phrase it the other way around. So, like you mentioned, transfer or connections can be open for minutes or hours or whatever. So there can be some sort of lag between like when a file is opened and when it's like reported back to the monitoring databases. One thing that we have difficulty with XRootD is that it doesn't really give you a good idea of what is currently happening on the server. Which identities are connected and which files are accessing. Is there a provision, or can there be a provision in the future to actually get sort of a live view of server X has 35 connections from this IP address and yada yada yada, or would it just be strictly sort of an after the fact kind of monitoring kind of thing?
We don't have that right now. I'm not fluent on what you can get out of XRootD. I don't know that you can get that from it by querying it somehow. And getting it from this monitoring flow, it might be somewhat accurate. Again, because of a few buffers within XRootD, it might be a little bit delayed, but not more than a minute or two, so not that bad. I think you might be able to do this with this monitoring packet flow, but we haven't really investigated it.
Great. Well, thanks a lot again. Derek?